Hey, welcome back, students. In this video, I want to go ahead and talk to you about extensive properties. Now, extensive properties, if we kind of look at these two words and break them down, remember the properties were essentially referring to characteristics of the matter in question. Okay. And the other item here is when we look at these extensive, the idea here is kind of think of this in general terms. Whenever we talk about extensive, it kind of comes from that root word, the extent of something, and the extent of something is always going to be referring to the amount present. Okay, this amount or this quantity. Now, the reason that this is important is because if we take these two items here, the matter that we're referring to here in terms of the property is going to be the following. That is, the extensive property is a property that is dependent on the amount present. Of matter present. Now, why is this important? Because the amount of matter that is present, that's what's referring to the quantity of things. And so if you start off with a sample of matter, and let me go ahead and kind of make this a little bit smaller here. Let's see if I can reduce this a little bit here and give me some space. And the idea here is, if I were to take some, let's say I take just a rock of some sort. Okay, let me just say it's a little pebble. Let's say this is a rock. And if I go ahead and measure this and put it on a scale, okay, so that's the thing I'm going to do here. Let's say that I got this scale here. Okay. And let's say here, scale. And if I place this rock on that scale, so let's say that I take this rock and I put it on the scale. And let's say that the scale then is going to read here, let's say that it reads 5 grams. Okay. Now, the mere fact that I've got only one rock here on the scale, it gives you a certain amount of that mass that's applied to this specific amount of matter in the form of the rock. But what if I come in here and I say, well, I don't have just one, I actually have two of them now. Okay, so if one is equal to 5 grams, what if I had two of them? So now I'm going to double this amount here. I've got two of them. And so essentially here, what I've got here is, if I've got this here at 5 grams, and I've got this at 5 grams here for the second one, if I add them here, what you're going to wind up seeing is that here I'm going to have 2 rocks, but the total mass here is going to be 10 grams. So naturally here, when you look at this, if you increase the amount of matter, so here we've got one piece of matter, here's another piece of matter, assuming they're the same sizes, the mass then is going to increase by the number of matter that I have present, so the quantity changes. In this case, the quantity doubled. You have 2 rocks present instead of just the one. Therefore, the mass is going to increase. Assuming the matter here is the same, you see that the mass doubles for that sample. If I have 3 rocks, then I would have 15 grams, because that would be 3 times the mass of the one rock. And so in this example, you can see that the amount that you have actually is going to affect the measurement. In this case, the measurement that we're looking at is matter in terms of mass. And so there's a whole bunch of these properties that we look at. And so let me give you a couple of them so we have reference. Put this in red. A couple of these examples here. Let's put this over here. Mass is one of them. It's just the one I just provided an example for. But there is another one, for example. Let's say that we have length. Okay. And so what we have here, let me just give you an example. I'm going to go ahead and erase the stuff here at the bottom. Okay. So let's go ahead and erase all of this. We don't need any of this. So if I erase all of this here, I'm going to go ahead and write the stuff here at the bottom. I don't need this either, so let's go ahead and erase that. And so what we've got here is, let's say that I have just a simple little thing. Let's say that I have a car. Here's my generic car here. Okay, and there's the car. Yeah, I know it's a funky looking car, so just bear with me. Let's say that we have this car here. Okay, and in this car here, what if I went through and I measured it from this point here all the way over here. And let's say for the sake of argument that this car is approximately 8 feet long. Okay, I know it's not a very big car, but you got a ruler and you measured it. So if I have this car, what if I were to take a very similar car, but let's say that I get the extended version. Maybe I get one of these, instead of a compact car, let's say that I get a full sedan. So the sedan here, let's go ahead and draw this in green. The sedan would be just a little bit longer there. Okay, and they're facing to the right, and here's my generic looking car there. Okay, and so the idea here now is if I take this and I measure it from here all the way to the bumper here at the very front, this now, if you can see the distance here, let me go ahead and duplicate the length here. Let's do this like this, and you can see now that if I take this measurement over here, notice here the distance here for this one is 8 feet, but notice if I put it here now, notice the distance is slightly different. Okay, notice now that the length of the car is here, so the extra piece is this other piece. I'm going to put it, I guess I'm going to use the color red now. This extra piece here is the extra part, right? An extra length. And the reason that it's extra length is because now we have essentially extended how much a car is present, so therefore the length is going to increase. So length is another one of those properties that we're looking at matter, so that if we increase the amount that we have, clearly in the case of mass and in length, that amount for the mass and the length respectively is also going to increase. The same is true if you decrease it. So if you have less matter present, the mass should decrease, and if you have less of a car present, then the length of a car should be less as well. Okay, so those are two of them that we have there. There's another one here that we're going to look at as well, and that would be the things like, for example, volume. Okay, and so there's obviously more, but let's do this example here. Let me go ahead and erase this section down here at the bottom. Let's erase this. Don't want that anymore. And let's go ahead and maybe I should just make it smaller. So let's just move this over here to the side and move this over here as well. And so what we'll do now is let's go ahead and separate this out. And let's talk about volume. So let's say that I have a glass. And so let's say this glass is here. And in this glass here, I fill it in with a certain amount of, I'm going to go put inside here some H2O, some water. And so there's the water. Okay. Now, if you measure it, if you're able to come in here, let's say that this particular glass had a certain level of graduations on the side that you can actually measure. And if we look at the measurement here, just for the sake of argument, let's kind of make it up to the second line here. And let's say that each of these lines here represent essentially 10 milliliters. So there's 10 milliliters there. The second one would be 20 milliliters there. So if you look at that measurement here for 20, so we know that in this particular thing here, in this particular sample, we could say that at this point we've got 20 milliliters at the first attempt or the first measurement. What if we were to add a little bit more water into this? Well, let's put that in green, and so that would mean that we would have a little bit more here. But notice if I add more water to it, then that means I'm going to have 10 more milliliters here overall. So when I consider the overall total volume, that would be essentially 10 milliliters plus the 20 milliliters that we had there, giving me a total of 30 milliliters. So again, here you see that if we increase the amount of sample that we have, the amount of matter that is present, we are going to increase the measurement or the units of that measurement that we're getting for the volume. That is also going to increase. If we go ahead and reduce the amount, let's say that you go ahead and empty a little bit of this water out here, well, then the measurement goes back down to 20. And what if we were to erase this maybe a little bit more? Now you would have 5 milliliters. So the idea here is that you're able then to go forward and take measurements, increasing the mass, the length, and the volume as you increase the amount of matter that you have present. But if you make changes to reduce that matter, each of these three properties here, mass, length, and volume, should also decrease. Okay, so if you haven't already done so, go ahead and subscribe, keep watching, keep learning, and we'll see you in the next video.